Okay, so in this problem, the pilot of a hot air balloon sees a field straight ahead and knows and that he knows, sorry, is 100 feet long. The angles of depression to the ends of the field are 25.4 degrees and 34.7 degrees. What is the height of the balloon and its horizontal distance from the nearer end of the field? Okay, so here I'm picturing we've got this balloon here, right? And the balloon's flying along, and there's this guy inside the balloon. So this is my balloon, and here's the basket, and he's in here, okay? He's in the basket. And ahead, he sees this field. Let's color our field green. And what does he know about the field? Well, he knows how long it is, and that's, of course, going to be a really key observation, right? This field from end to end, he tells us, is 100 feet. Okay? And, initially I was picturing the hot air balloon was above the field, but then I saw the word nearer. So that means that he's approaching the field, and let's call the nearer end N and the further or the far end F. And the line of sight, we have to have a point of reference. Let's say it's up here, right? The balloon looks across up here on this line, and the angle of depression goes down from that line. So I'll draw a red line to the nearer point. Oops, leave my line tool. Right? There's a line here. And then there's an angle of depression going to the far end down here. Okay, so first of all, we have these two angles that they give us. Which one corresponds to the nearer part of the field? The higher angle or the lower angle, the smaller angle? Well, the angle of depression is measured from this yellow line. So the larger angle measurement goes further from the yellow. And when you look at it that way, we realize this larger angle must represent the red line. It must represent the nearer part of the field. That's the 34.7 degrees. And in this scenario, right, with angles of depression, a smaller angle means you're looking further away, right? If you look at the way this is set up, you can see why that might make sense. And what are we trying to find? We're trying to find the height of the balloon. So the height of the balloon is whatever moment in time this is happening, right? That's set. This height right here is constant at that moment. So we can use that as a reference here because we want to find the height of this balloon. We need a reference point. So now we've got it. Okay. So what else can we do? All right, well, here, right, the height of the balloon we'll call h. So let's just, even when, if you're stuck on these problems, start labeling this with your variables. And what do we know? Well, we know that f, right, is 100 feet away plus x, this distance right here. Or we'll call it, we'll call it x. So that distance is unknown. We don't know how far away the balloon is from the field. We just know it's some distance. So once we have that, we can start setting up our equations. So here, with the angles of depression, how is this going to help us? Well, these lines we just drew are transversals, and we can assume that your line of sight is parallel to the ground that you're over, assuming it's not too mountainous or hilly. And so if the ground is parallel to the line of sight up here, that means this line is a transversal. We have this angle, which is equal to 25.4 as well. That's that alternate interior angles are equal, right? And once we have that, now we can say that the tangent of that angle, we can use an angle of elevation. The tangent of this angle is going to be equal to what? Well, it's going to be equal to the height of the balloon, the opposite, because tangent equals opposite. And if you look at our large triangle that we're dealing with right here, right, just going to kind of sketch it around here, has the 25.4 degree angle that we're using as a reference, and the height is the opposite side of that right triangle. And the adjacent side is x plus 100 feet. Sorry about that. So, okay, so the adjacent side is x, wrong tool, x plus 100. Okay. And this, you might feel like, oh, well, having x plus 100 doesn't actually help us. Well, it will help us once we have both equations to work with as well. Sorry, this pen is wearing out on me. Okay. And what about the other triangle? Well, here this smaller triangle, we can outline it as well, right? A lot of these similar things happen. Again, 34.7 degrees, alternate interior angles are equal. And this time we'll just write that the tangent of 34.7 equals the height over the adjacent side, which in this case is just x. And now we have two equations with two variables, h and x. That means we can solve for one of them. So we want to solve for the height. That's our goal. How high is the balloon? So in this equation, I'm going to multiply both sides by x. That will give me x times the tangent of 34.7 degrees equals our height, right? And over here, it's the same height. I'm just going to multiply both sides by x plus 100, getting rid of those denominators. It's the exact same strategy, right? If you just think back to simple algebra steps, h divided by something equals this number, so we multiply h by what we're dividing by to get the number. So if we're dividing by x plus 100, multiply by x plus 100. So anyway, we get the tangent of 25.4 equals h. And again, I apologize, this pen is just wearing out on me. Okay. So does this help us? Sure. H equals x plus 100 times the tangent of 25.4, and h also equals x times the tangent of 34.7. H equals itself, so we can combine these two equations. We have the tangent, x times the tangent of 34.7 equals x plus 100 times the tangent of 25.4. I want to solve for x, so tangent of 25.4 is just a number. Going to distribute, multiply to both numbers in here, and we have x times the tangent of 25.4 plus 100 times the tangent of 25.4. This is my plus sign in here. And that equals x times the tangent of 34.7. Don't be overwhelmed by all these tangents. Those are just numbers. And because they're just numbers, I want to get my x's on the same side, right? So subtract x times the tangent of 25.4. So I subtract this on the right, what's going to happen? Well, anything minus itself is 0. I have to balance it by subtracting it on the left, right? 25.4. And here, what do we have on the right? We have 100 times the tangent of 25.4. And here we have x tan of 34.7 minus x tan of, no, I'm not saying tangent anymore. It gets exhausting to say. So just say tan and save some time. And what is this? Well, x is a common factor. Factor it out. The tangent of 34.7 minus tan of 25.4. Once x is factored out, we can solve this. Now, it might, these kind of algebra problems, I think, they look intimidating, but really, all we're doing here is solving for x. It's a simple algebra problem where we're solving for x. And it might not appear that way, but all we have to do now is divide both sides by the tangent of 34.7, right? Basically this whole chunk right here, minus the tangent of 25.4, right? Do it on the right as well. And it's just a bunch of numbers that we're dividing, and it would be really tedious to have to look these up on a table and solve step by step, but really all these values are manageable, I think, once you work within the calculator. So these values cancel out, and then I'm just going to enter these here, right in my graphing calculator. And that will be the value of x, which I can then use to find my height. So again, sorry about the handwriting, the pen is really not working too well. Okay, so in our numerator we have 100 times the tangent of 25.4. I like to hit enter, so that gives me my numerator. Okay, that's my numerator, 47.48, 3, 4, 9, and 1, 1. And then I just press divide, it carries that answer with me. And in parentheses, tangent of 34.7, right, close parentheses, minus the tangent of 25.4, right? Okay, close parentheses, enter. Okay, so the total distance here is the distance x is 218.216619, and that distance x is this distance to the field. So my model here is not to scale, right? Because this x here should be longer than the 100 feet in total. I'm going to use the red equation here to solve it because it's most direct, right? We just do x times the tangent of 34.7 to solve for the height. So how do I do that? Well, I have x here. I just press times the tangent of 34.7, and we'll have the height of our balloon, about 151.1003803, about 151, I believe, meters in this problem. 100, sorry, it's feet, so about 151 feet in the air. All right, hope this helped.